Hello, in this video we will practice how to solve polynomials. So let's say we had x to the fourth minus 5x squared plus 4 is equal to 0. By knowing everything we have learned, we see that this function could actually become a quadratic function just by substituting x squared by another variable. Let's call it y. So if we substituted x squared by y, we would actually get y squared minus 5y plus 4 is equal to 0. And here you can see that this is just a quadratic function to which we can apply either the quadratic formula or factorization very easily and get the zeros of this function. After we get the zeros of this function, we just have to plug it back into x squared is equal to y, and we will be able to find the zeros of the original function. So now let's work first with the quadratic formula. So here we have y squared minus 5y is equal to plus 4 is equal to 0. And if you remember, the quadratic formula is x is equal to negative b plus or minus the square root of b squared minus 4ac, all of this divided by 2a. Very well now. Knowing the formula, now we just have to plug everything in. We know that the coefficient of the y is b, the coefficient of y squared is a, and the constant is c, the constant term. So now we just have to plug everything in. So we said that a is equal to 1, b is equal to negative 5, and c is equal to 4. And so if we plug this in, we get 5 plus minus the square root of 25 minus 4 times 1 times 4, and divide this by 2. Well, 2 times 1, which is 2. And now we can simplify 5 plus minus the square root of 9 over 2. We know that the square root of 9 is 3, so 5 plus minus 3 over 2. And this gives us 4 and 1. We get 2 solutions. So now, as you might recall from before, this is the solution to our modified function. However, it's not the solution to the original. We need to transform, so 4 and 1 are our y, and to get the x, we must find the square root of both sides, and then we get x is equal to square root of y, and if we plug in 4 and then 1 for y, we get that x is equal to 2, and also it's equal to 1. These are the zeros. However, you know that actually when you get the square root, it's plus or minus, because if you were to put negative 2 squared, you actually also get 4. So don't make that mistake. Always remember that when you are getting the square root, it can be either positive or negative. So this is actually plus minus 2 and plus minus 1. So here we see that our our function crosses the x-axis twice at positive and negative 2 and positive and negative 1. But now let's use another way of finding the zeros. So here we will use factorization. So as you might recall, this is the modified function that we found. Y squared minus 5y plus 4 is equal to 0. As you might recall from a past video, we could factorize this by saying that the constant term is equal to sum a times sum b, and that is equal to 4. And then we know that that same a plus that same b will give us negative 5, which is the coefficient of the y. Now, something to keep in mind is that if we had a coefficient right here, we would have divided everything by that coefficient, but in this case, our coefficient can be thought of as 1, and then we have a 1 here, and so if we divide everything by 1, it's just like keeping it the same. So in this particular problem, we don't have to worry about that, but I just wanted to remind you what would have happened if we actually had a coefficient right here. So just by inspection, can you find an A and B that can solve these two equations? And yes, you can. You could have also done substitution and things like that, but here by inspection it's really easy to find that A is equal to -4 and B is equal to -1. A side note, this could be flipped. It's exactly the same thing. You could have said that B is equal to -4 and A is equal to -1. It doesn't really matter, but I just put it in this order. So by having this, we know that y minus 4 and y minus 1 are our factors of this modified equation right here. So now, by having these two factors right here, we can actually find the 0. We know that if this first factor is equal to 0, our whole equation would be equal to 0 like we wanted to. So y minus 4 is equal to 0 will be one of our zeros. Then y is equal to 4 as being one of the zeros. Same thing with the second one. If y minus 1 is equal to 0, then our whole equation will be equal to 0. So we need to find that 0 as well. And by doing so, we have found the zeros of this equation. Now, as you might recall, this is exactly the same thing that we got when we used the quadratic equation. And so just by doing exactly the same thing and transforming our y to x, we would also find that x is equal to plus or minus 2 or plus or minus 1, that those are our four zeros. Just to prove that everything makes sense, I will show you the graph, and you will see that we actually do get the same zeros if you use graph, quadratic formula, or factorization. Again, so this is the graph of x to the fourth minus 5x squared plus 4, and we see that we cross the x-axis 4 times, and it's exactly at +1, +2, -1, and -2. Exactly what we predicted and what we said. So everything comes together and they all agree with each other, which is very important.